Welcome back everyone to Data Science for Everyone. Today we're going to be looking at financial data with Python. Let's get started. So first off, we want to have some basic imports. So let's import pandas as PD, import numpy as NP, import seaborn as SNS. Let's import matplotlib.pyplot as PLT. And we also want to import finance as YF. Now I haven't installed yfinance yet, and so if I do pip install yfinance, I can run that, and then I'll speed up time here for a minute, and we'll get back to it. All right, as we can see, it has installed successfully, and I'm gonna go on and kind of clear this up a little bit so it's not taking up so much space here. Now we have yfinance. Let's go on and run that, and actually let's also add in here matplotlib inline as well, so everything is running the way that we want to. Now we're going to be needing some financial data. Okay, so let's go on and let's actually go on and make up a dictionary, because we're going to be doing a couple different things. I kind of want to have everything nice and clean. So let's do something like, let's call this stocks here, and we're going to create a dictionary here, and we want to have a couple things in here. So we want our stock ticker. Okay, and then we're also going to have in here a stock name. And you'll see why later on. Again, this is just going to be for us to have ease of have everything kind of in one place, and we'll be able to reuse this a lot in the future. So let me pause everything here while I type this out, and then we'll go and discuss it in a second. So as we can see here, now we have a list of some nice stocks. We have Apple, Amazon, the Chinese US dollar exchange rate, gold price, we have gold trusts, we have Goldman Sachs stock, we have Intel, we have Microsoft, and we have the S&P 500. So this is going to be useful for us when we're wanting to grab our stocks and also do some labeling later on. So let's go on and actually get this data, if we will. So one thing that's nice about utilizing this dictionary now, we can do something like stocks, whoops, not store, stocks.keys. Okay, and then it'll do something like a list. We'll have to see here if we actually have to run it or not. But let's do something like our DataFrame is equal to yf.download. And then we'll do stocks.keys. And let's see, do we want to do, let's just do everything that's available for us. Oh, and it doesn't take that dictionary key. So let's do, again, list of that. And this will gain all of our stocks that we are interested in. So let me maybe zoom in a little bit more for you. So now if we take a look at our data, we'll see here that we definitely are doing okay. However, we have a lot of missing values, and so we'll take care of that. And then also here, notice that we have these, we have these nice sections here of each of the type of stock. So for example, here it's the adjusted close, high, low, open, volume. So if you want a specific one, you can grab each of them. And today I think we're just going to work with maybe the adjusted close, but we can also see here at how much we're missing. So let's do df.info and take a look. And again, you can see here that depending on the age of the stock, we have more, we have less. So again, Apple is an older stock than most of these, so we'll have a lot more of that data available to us. And notice also they are also all float 64, but we're also missing quite a bit of data. And it's not very big in size either, so that's not something we need to cause much worry about. So let's go on and grab just the adjusted close here, and let's grab this with just adjusted close. And then we can also, again, now just take a look at what that looks like. And we see here, again, we're missing quite a few, but we're not doing, we don't have to deal with those double headers, okay, or anything like that, but we do have our nice date in here. So let's also go on and go back and let's actually just plot this right out of the bat. So let's do something like adjusted close dot drop NA dot plot, and let's do subplots is true, and let's do our fig size here to be something nice and big, so 12 by 10. Run that, and we will see here in just a second that we have a nice plot here with all of our values. And I'll zoom out just a little bit so we can see everything together. And again, we have a nice grouping. Okay, now a couple things that we may eventually want to work on. For example, see that this GDX here, maybe we want it over here. Or another thing is, notice that these are all the tickers, right? So maybe we want to do something a little bit different with that. Maybe we want to use the names or something else. Now notice this is also very nice since we got rid of all the missing values. So we're going to actually do this and drop this in place. So let's go on and say adjusted close dot drop NA. And then we also want to go on and take a look at everything together, okay? So what are our column names that we're looking at, and what is the actual price range? So what we'll do is we'll take this dictionary that we created at the beginning, and we'll say something like for key value in our dictionary, and it was stocks dot items here, and then we'll do something to make it look a little bit pretty. So let's do something like print F here. Oh, whoops, not F, we want an F string in here, and we'll do something like our key, and we want this to be something like 8 spaces for a string, and then we will give it a nice column border there, and then we'll also give it a value there, and let's go on and just run that. And now we can see that we have all of our stocks and everything. We can also make it look maybe a little bit prettier or something if we want to later on by putting in borders or anything else. But this is nice just to kind of show this is what we're doing. We can kind of keep it in our mind as we look at things. So now let's actually do the summary statistics for our adjusted close. So adjusted close.info. We'll take a look and notice now, since we've done the drop in A, we have everything is full. We're not missing any values. We have everything from 09, 02, all the way up to 2020, 04. Okay, so let's also go on and do our descriptive statistics. So descriptive statistics is very easy, as we've seen in plenty of videos. But again, it doesn't hurt to reiterate on what we already know. So we have our nice descriptive statistics. And again, if you guys are using Colab, they now have a nice interactive table. Okay, so we can actually play with this a little bit, so it has this nice interactivity to it. And again, that goes with almost anything in there. So I just thought you guys may want to play with that a little bit. So we can also do just some basic statistics as well for .mean. We can also, and probably my personal favorite is using the aggregate method. So we can do adjusted close.aggregate. And here you can put in a list. So for example, you want the min, you want the mean, you want the standard deviation, you want the median, and you want the max. Whoops. Max. And again, all you do in here is put in whatever function that you want, and you'll be able to run that statistic. So again, you can make up your own function if you want, and then just put the function name in there. Do round 2. And so again, here we notice that, and notice this is kind of nice too, because it knows what these are. So it actually changes these aggregate functions to min, mean, standard deviation, median, and max. So when we have all of those nice, slightly customary statistics in there. And again, you can do these for anything that you would like. So let's also look at changes over time. So the next portion that we definitely want, and particularly when we're talking about stocks, again, is change over time. So how are we going to look at change over time? Well, first thing that we always like to do is we like to look at the differences. Okay, so the difference between period 1 and period 2. So if we do use the diff, and we'll just grab the head here, you'll see that it changes and it checks the change, the daily change between those. And again, if we're using high frequency data, it'd be the change maybe between even nanoseconds, okay? But and again, we're also going to be missing that first row, so we do have to give up a single observation. So if you're dealing with low observations, that's something you may need to worry about, particularly if you're taking like the second or third. So again, we can do something like 3 in here. And notice it's for every third. So again, most of the time we're doing just the differences from the first day. And we've also had, we can also do maybe the mean of the differences. So we can also do dot mean in there to do the mean of the differences. So this is, for example, this would be very close to like the returns. Okay, but again, if we're going to actually create up returns or something, we probably want to do the log. And we'll do that here in just a second. Now the next one that is probably more used and is more useful personally, I believe, is just to use the percent change. So adjusted close dot percent change dot round, and we'll do it to the third, and then we'll do the head. So here, this is the nice percent change. And notice here, because again, when you're doing that, you're doing the differences, so you're going to be missing a singular value in there. So you'll also probably want to drop those missing values whenever you do something of the such. So now let's go on and do a quick bar graph of the percent changes, the mean of the percent change, let's say. Okay, so let's do adjusted close dot percent change. We want the mean of the percent changes. We want to plot this as a kind is going to be bar. And let's do fig size here of something like, I don't know, 10 by 10. Run that, and then notice here, now we get this nice bar graph. And again, maybe I need to zoom out a little bit, or maybe I should make it a little bit smaller. Maybe we'll do something like, I don't know, 5 by 5 for now, make it real tiny. So it fits in there. So notice that we have our nice bar graphs here of the mean of the percent changes. So again, you can see which ones may be a little bit more volatile in their changes over time. Now we would also like to look at the returns. So let's do returns is equal to the log of the adjusted close divided by the adjusted close. And now we need to shift by 1. And let me actually, before I do that, let's do adjusted close dot shift 1. So you can see here what it actually does is it moves down those values. So if I do something like print adjusted close head, and then we'll do dot head as well, and let's do print. So you can see what happens here is this is the original value for the second. Now when we shift those values, okay, it is just moving them. Again, maybe look here and here. All right, and I'll grab a pen to write with real quick. So you can see here, these guys and these two are the same now. Okay, so everything has shifted down 1. All right, that's what the shift does. So again, you can also do shift 2, 3, etc. So when we want to do that, and we actually want to create up the returns, then is the log of the original, so that's this guy up here, divided by the shifted one, which is this guy down here. Okay, and so that's going to give us our returns, and again, it's the log of that division. So now let's take a look and see how this is going to be growing. So if we do something like returns dot cumulative sum dot apply here, and we want the exponential, we'll do plot fig size here, and let's do something like 10 by 5. And then we can actually take a look at our returns. And now notice this is quite nice here. We see all of them together. We can see that there's definitely, we have Apple and Amazon are definitely growing. And maybe we wanted to do this in maybe a subplot. If you wanted to, you can say subplots is true. Run that as well, and it'll split everything up for us. As we can see, but this is definitely not very, I don't know, I don't find it very useful. It doesn't look very good, so I'm going to go back. I prefer this one. And then we'll go on to resampling, and we'll talk about our resampling methods. So resampling is grabbing and adding in, for example, like if you want to find maybe the weekly high or the weekly max or the last of the week, okay? Whenever you're resampling, you're just going to be grabbing what you want from that. Well, we can do adjusted close.resample, and that's at one. Let's do resampling at 1 week. Label here is going to be right, and we want to grab the last of those, and let's just grab the head. So notice here we've done a nice resampling. And then we can also do the same thing, like if we wanted to resample for a month. Again, it would be, let me just grab this and I'll paste it down here. We will want to resample with 1 month. Okay, so the W changes to an M here. Run this, and then this is resampling for a month. So if you look at our changes over time. So if I run here, notice this is basically done by days. Okay, so 5, 6, 7, 8. And then if we come here, notice now if we're doing weekly, it's 4, 11, 18, 25. And then again, we go back to 01 because it's doing for every week. Now when we are grabbing for the, excuse me, for the month, again, it's going by singular month, and it's grabbing the last value. Again, you could change this to something like the mean if you wanted to. If you want the first value, you could do the first value as well, okay? Just depends on what, how you're wanting to do your analysis. So the next thing is let's go on, and here we are looking at the cumulative sum, okay? We have our exponential, again, to take care of the log that we had used. So we're going to take this again. But what we're going to do now is we're going to go on and resample this. And we'll apply here. And we'll do resample at 1 month. Label is going to equal right. And so now we get the monthly returns, and this will be a nice little condensed graphic for us once we have this run. Now we can see here something definitely went wrong, okay, as you can see, because I did the resampling. However, I did not tell it to grab the last here. So it tried its best to kind of fill everything in. So you need to make sure that you have some sort of aggregator at the back, okay? So the mean, the last, the first, the max, the min, something. You need that aggregator. So now we actually have our returns in here. And as you can see, this gives us a nice growth of returns over time for each of these. And later on, you could maybe do some analysis. You could add in, for example, some annotation to say something like, oops, what happened in this area here? Why is there nothing happening here? Okay, and notice, for example, some of these are really flat. So you could add in annotations as well. But this is just the basics and a really simple look at financial data. In the next episode, we'll be looking at probably doing rolling statistics. Okay, so we'll be doing statistics to see, for example, what maybe the average is over time or anything else. So if you guys like this, please comment, subscribe, and hit that like button, and I will see you guys next time. Bye-bye.